G'day. Have you ever wanted to add together algebraic fractions like these two here, and no matter how hard you tried, you just couldn't do it? You just felt like... Well, don't worry, because I'm going to show you how to do that. Okay, the first thing I need to remind you of before we can do this is the special names for the different parts of a fraction. The bit that's on top of a fraction we call the numerator, and the bit that's on the bottom of the fraction we call the denominator. So lock those into your brain. That's what I'm going to be referring to those as most of the time. Now, it's very easy to add numbers that have the same denominator. They have the same number on the bottom, because when you've got the same number on the bottom, all you have to do is add the numbers on top together. 1 plus 2 is 3, and the bottom stays the same. So 1/4 plus 2/4 equals 3/4. That's really easily demonstrated using pictures too. So if we've got 1/4 of a pizza and we add 2/4 of a pizza, then of course we're going to get 3/4 of a pizza. Okay, so the lesson from that is what we need to do when we've got problems like this one, x over 2 plus 2x over 3. What we need to do is get the same number on the bottom of both of these fractions, like we did here. We had the same number on the bottom as the denominator. Once we've got the same number on the bottom, then we can just add the tops together, nice and simple. So how do we get the same number on the bottom? Let's look at how to do that. Okay, the secret to getting both of these numbers on the bottom to be the same is to multiply each of them by 1. Now that might surprise you at first, because multiplying by 1 usually doesn't do anything, but watch this. Watch what happens when I multiply this by 1. Suddenly it becomes... oh wait, that didn't work. It's still the same. Okay, I think I know what I have to do. So multiplying it by 1 like that didn't change it, but what if I multiply it like this? Okay, 3 over 3 is just another way of saying 1. 1 over 1 equals 3 over 3 equals 10 over 10. Anything divided by itself just equals 1. How many 3's are in 3? 1. How many 10's are in 10? 1. Okay, so this is another way of saying multiply it by 1, but this is going to do something different. Watch what happens here. When you have a fraction times a fraction, you do top times top and bottom times bottom. So on top I'm going to have 3x, and on the bottom I'm going to have 6. Okay, terrific. Now I've got the same fraction. Notice, because I've multiplied it by 1, it hasn't changed what the fraction is. This is still equal to x on 2, what I had at the beginning. But now it looks different. It's got a different number on the bottom. Okay, so now I know something really helpful. I can change the number on the bottom to be whatever I want by multiplying the fraction by something over the same thing, by multiplying it by 1. Okay, so the next question is, what number should I choose to make both of these fractions to be so that they'll have the same denominator? I can choose any number I want. I can make the 2 become a 6 or a 10 or a 20, whatever I want, and I can do the same with the 3. But the trick is to find the smallest, easiest number to make them both the same as. Okay, to choose the best number for making these two denominators the same, we have to find what's called the lowest common multiple, or LCM for short. Okay, we have to find the lowest common multiple of the 2 and the 3. Sometimes you'll hear it called lowest common denominator. It really means the same thing. We're finding the lowest common multiple, but because they're also denominators, sometimes people call it lowest common denominator. Okay, how do you find the lowest common multiple? Well, it's very easy. All you have to do is make a list of the multiples for each number. So for 2, the multiples would be 2, 4, 6, 8, 10, and so on. For 3, they'd be 3, 6, 9, 12, 15, and so on. You could keep those lists going on forever and ever, but we don't need to go too far, because the idea of making those lists is to find the first number that's common to both lists. In other words, the lowest common number that's in both lists. And that's another name for that is the lowest common multiple. And you can see it's 6. 6 is the lowest common multiple. If we kept going with our list, we'd probably find other numbers that are common to both lists, but 6 would have to be the lowest. There's nothing lower than 6 in both lists. So 6 is the lowest common multiple. Okay, what do we do with that? Okay, don't worry, we're nearly at the end. Okay, so we know that we need to turn both of these denominators into 6. We want to get them both to become 6. How are we going to do that? Okay, well, to turn 2 into 6, here's what you would do. You've got x over 2, and you want the 2 to become 6, you'd multiply it by 3, and you'd get 6. And that tells us what we need to do on the top as well. If we're going to multiply the bottom by 3, we have to multiply the top by 3 as well. Otherwise, we'd be changing the fraction. Okay, and by multiplying it by 3 over 3, which is 1, we're not changing the fraction, we're keeping it the same. X times 3 equals 3x. So this is our new expression for x over 2. It's now 3x over 6. Okay, now we do the same for the other one, 2x over 3. Now how do we get 3 to become 6? We multiply it by 2. And since we're multiplying the bottom by 2, we've got to do the same to the top. So we get 2x times 2 on top, which is 4x, and on the bottom we've got 6. So that's our new expression for 2x over 3. It's 4x over 6. Now notice, this is very important. Both of these fractions are equivalent. They are equivalent. They're not different. So they are different, but they're really the same. They look different, you could say, but they're not actually different. These are equivalent fractions. They're both the same as each other. Just looking a little bit different. Okay, let's rewrite these two fractions now as our new expressions. So we've rewritten them as 3x over 6 plus 4x over 6. And now that we've got the same denominator, the same number on the bottom, we can just add the two things on top. 3x plus 4x equals 7x. Okay, if you're not familiar with adding things that have letters in them, imagine it's 3 apples. Instead of 3x, it's 3 apples. If you got 3 apples and you add 4 apples, you get 7 apples. You add 3x and 4x, you get 7x. So don't worry about the letters. Just treat them like anything in life. If you've got 3 of something and you add 4 of the same thing, you've got 7 of those things. So that's what it would become, and that's how we would simplify that. That's how we can add two algebraic fractions together. Okay, let's do a couple of examples of some other problems just to make sure we've got this down pat. Okay, let's try and do this. 2y over 3 minus y over 4. So we've got different denominators, so we can't do a straight subtraction of the top two things. We have to get the same number on the bottom. Okay, we've got to find the lowest common multiple of these two numbers and then rewrite the fractions with those denominators. Okay, the lowest common multiple of 3 and 4, if you know your times tables, is going to be 12. Okay, so we've got to get both of these to become 12. 2y over 3. Okay, to make that become 12, to make the 3 become 12, we'd need to multiply it by 4. So we do the same to the top and the bottom, and we get 8y over 12. And for the other one, we've got y over 4, and we know we want it to become 12. What do we need to multiply 4 by to make it become 12? 3. Okay, and we do the same to the top. So we've got 3y over 12. Those are our two new expressions for these two fractions. So let's rewrite it now with those new ways of expressing. Okay, so here's the problem rewritten with the same denominator now, and we've got 8y on top minus 3y on top, so that just becomes 5y, and the bottom stays the same, 12. Easy. Okay, now here's a tougher one. If we can do this one, we can probably do just about anything. The problem's exactly the same. We don't have the same denominator, so we can't add these fractions, or subtract them for that matter, together. So we need to get the same denominator. We need the lowest common multiple of 2 and 3, and that's going to be 6. Okay, so we need to get both of these fractions to be multiplied by something so that they get 6 on the bottom. So the first one, 3x plus 1 over 2, if we want to multiply that by something that will give us 12 on the bottom, then that's got to be 6. 2 times 6 will give us 12. Okay, and on the top we've got to do the same thing. So on the top now we've got 6 times 3x plus 1, and we've got to multiply the whole of this top by that 6. So you could imagine it's like this: 6, 3x plus 1 in brackets like that. Okay, now the 6 gets multiplied by both of these things. 6 times 3x is 18x, and 6 times 1 is 6, and that's all over 12. So that's the new expression for the first fraction. Okay, for the other one, we've got 5x plus 2, and it's all over 3, and we need to get that bottom denominator to become 12. How do you get 3 to become 12? You multiply it by 4. Then do the same on the top, and you'll get 4 times 5x plus 2. If we expand that out, 4 times 5x is 20x, and 4 times 2 is 8, and it's all over 12. Okay, now we can rewrite the problem with these two fractions that have the same denominator. Okay, now notice that we've got in this new expression, we've got 18x plus 20x, so that's going to give us 38x, and we've got 6 plus 8 on top, which gives us 14, and this is all over 12. Now we can actually simplify this a little bit because all of these numbers are even, so we can divide them all by 2. If we divide them all by 2, we get 19x plus 7, and on the bottom we get 6. So we can simplify it a little bit. That would be the simplest way we could express that. Now, just to give you a little heads up, you might come across a problem where instead of a plus, you've actually got a minus. Now, what would happen if you had a minus here instead of a plus? Here's how it would be different. You'd be doing 18x plus 6 minus all of this. Okay, all of this would be minused away. So this would become 18x minus 20x and 6 minus 8. Because the 8 is on this side, it's got to be minused away. Although it says plus there, don't be confused, it's not 6 plus 8, it's 6 minus plus 8. So we've got a minus 8 away from 6. And when we rewrite all of that, 18x minus 20x is negative 2x, and 6 minus 8 is negative 2, and that would be all over 12. And of course you can divide everything by 2 again, so you'd get negative x minus 1 over 6, just dividing all those things by 2. So that's what would happen if you had a negative there. You've got to make sure that everything here gets minused away, and not just the first thing, minus 20x, but also minus 8 as well. Everything in that second fraction gets minused in that case. Okay, really quickly before we finish off, there's two other, I guess, variations on these problems that might trip you up, so I just want to look at them really quickly. If you've got you've got one of the pronumerals on the bottom, like the x on the bottom, okay, don't get worried by that situation. The same thing applies. You've got to find the lowest common multiple of these two things. Okay, and that's going to be pretty simple. It's going to be 15x in this case. Okay, and to get 15x, you would multiply this one here by 3. What's this? 12 over 5x. In order to make that 15x, we'd need to multiply this fraction on the bottom. We'd need to multiply the bottom bit by 3. 5x times 3 will make it 15x. And if we're doing that to the bottom, we've got to do it to the top as well. So 12 times 3 would be 36 over 15x. Okay, this bit we wouldn't have to even change because it's already got 15x on the bottom, so we could just add that straight to 4, add it like that, 4 over 15x, add the tops, and you get 40 over 15x. Okay, so don't stress when you've got things on the bottom. The process is the same. Find the lowest common multiple. For this one here, it's a little bit trickier. Same process again, but just looks a bit more confusing. If you've got a whole bracket on the bottom like this, there's going to be no other way to get a common multiple than to just multiply these two brackets together like this. That's going to be the lowest common multiple when you multiply them together. Okay, now whatever you multiply this denominator by, you've got to multiply the top by as well. So for the first one, if we had 2 over x plus 4, and that's in brackets, we know that we're going to have to multiply the bottom by x minus 2 in order to get this denominator, so that means we have to multiply the top by the same thing as well. So we multiply both top and bottom by x minus 2, and that's going to give us 2x minus 4. 2 times x is 2x, 2 times negative 2 is negative 4, and on the bottom x plus 4, x minus 2. For the other one, we start with 3x and it's over x minus 2, and we know already that we have to multiply x minus 2 by x plus 4 in order to get that denominator that we want. We know this is the denominator we want to end up with. We have to multiply it by x over 4, so we're going to do the same to the top and the bottom so that we're still multiplying by 1. This is all 1, and that gives us 3x times x is 3x squared, and 3x times 4 is 12x, and that's all over x plus 4, x minus 2, brackets all round. Okay, and then we can add this and this together, add those together, add any like terms. You've got 2x and 12x, so that's going to make 14x. These two are just going to stay the same, and it's going to be all over this fraction here, this denominator rather. Okay, so hopefully that should be able to get you through the problems in the textbook. We'll just summarize what we've learned. Okay, finally here is a summary of everything that we've learned in this video, and you can pause the video here in order to copy it out. Remember, anything that's in yellow should be copied out, and after watching this video, you should be ready to take the quiz now. And if you'd like, even to have a go at maybe the first couple of questions before the next class, where we'll go into this in more depth and do all the exercises in the textbook. Okay, thanks for watching the video. I hope you enjoyed it.